great to be here. Great to have great panel members. I think everyone on this panel actually has worked on trustless interoperability, at some point. Um, I think we should do a bit of intro so that the audience kind of knows who's here. Sean, we can start with you.
Sure. Hi, everyone. My name is Sean. I work in Polkadot, and we, of course, have a system where many chains are connected through a trustless interoperable network.
I'm Susanna. I am the product lead for the IBC team. IBC stands for Inter-Blockchain Communication Protocol, and it's the interoperability solution which was first developed in Cosmos, but has much far further reaching ambition than Cosmos alone.
Hey, I'm Friederike. I'm one of the founders of Gnosis. Gnosis has its own chain, but it's very close to Ethereum. So I think I'm here the de facto Ethereum representative. Gnosis kind of approaches scaling in the horizontal scaling way, while most of the other scaling solutions on Ethereum kind of do vertical scaling, but it's very much one big space.
Hi, I'm Giorgio, Italian. I'm a newly joined CTO of the Cardano Foundation. And before that, I had my own SSI company. So I worked a lot with protocols and interoperability, verifiable credentials, etc.
Nice. Yeah, for sure. My name is Sean. I'm the co-founder of Polytope Labs, and we're actually building a multi-chain interoperability solution called Hyperbridge. So I guess I'm the perfect moderator for this panel. So let's just jump right in, actually. I think we should understand that we still have a very much fragmented ecosystem, a multi-chain ecosystem. We have XCM in the Polkadot ecosystem. We have IBC in Cosmos. Friederike, you guys are one of the first people to build a sidechain and a bridge to Ethereum. What do you think is standing in the way of a unified solution that connects all chains, not just intra-ecosystem interoperability? And anyone, of course, on this panel can answer.
Yeah, maybe I can start. I think the key thing is to find the problem and solving it rather than thinking of a cool technology to bridge two chains and then see what happens. If we think of the most successful interoperability projects, those were the very simple one like ERC20 tokens or NFT protocols, and those enabled interoperability with exchanges, with wallets. And sometimes as an engineer, I'm an engineer myself, we think, oh, wouldn't it be cool to do zero knowledge transfer from Cardano to Polkadot? But then if we are not solving a real problem, we are not gonna get the adoption that we think we're gonna get. So I think the key is to look out for problems and fix them rather than think of technology first.
Yeah, I would second that 100%. So kind of how you end up with N+1 standards is by having N standards and then people getting together and saying, oh, wouldn't it be cool if we had a unified standard? So kind of building things for actual solution, for actual problems, I think that's the way to go. And I don't think it's actually important to have a unified, cross-chain solution. I think kind of like having a piecemeal solution kind of between any two chains, I think this is enough. And I mean, I totally understand kind of like from an engineer's perspective, I'm an engineer myself, so kind of I totally understand kind of this desire to kind of have this one all-encompassing solution that's kind of like, that's computationally in some way optimal. But I think having having an entire spectrum of different solutions is actually really good for resilience. And I think often, I mean, if you think back to kind of like why we're actually building things on blockchain, usually the reason is resilience, right? So kind of actually saying, look, okay, we have all these different blockchains and they're used for different things. And I think this is totally fine because they come with varying security assumptions, kind of in terms of kind of like who can run a node, what kind of consensus protocol do you have, what kind of programming languages do you allow, and so on, and then say, okay, now we'll all fit it into this one standard mold of kind of how they all speak with each other. I think you're shooting yourself in the foot a little bit. So I think kind of like having this patchwork of different different connectors, I think this actually works. I'm not saying every connector is great and should be around forever, but I think kind of it's an evolution, right? And I think having different legs to stand on, I think that's very much a plus.
So maybe to counter that point, I think like what's the value for a user who's going to use these solutions if they're like struggling to know exactly how they're going to move around or how they're going to use this product because there's just like, you know, too many possibilities and it's unclear what's actually going to deliver the value to them, or they're on this chain and they want to go somewhere else, but it's really unclear how they actually get there because like, oh, I actually need to use this bridge and then this bridge or whatever. So I think from a user perspective, the greater the fragmentation, this can be problematic. I do agree with like having more resilience and not having to just like rely on one, you know, blockchain or one project to do everything. And that's kind of like why we have this multi-chain ecosystem to begin with. But I think in terms of like a pure user perspective, how are they getting value out of these systems? Is it from having like 5 different solutions that they have to choose between, which are all providing an equivalent service? Or would they maybe be, I don't know, just competition's good, but to what extent?
Heated debate.
Can I just reply to that? So I think in due time, probably later this year or next year. So I hope that not a single user will actually have to actively choose a bridge. I think this is something that's going to be abstracted away from users more and more. So kind of we already see this, that kind of dApps already abstract that away from users. And I think intentionally bridging things, this is kind of an interim problem. So to me, this is pipes. It's kind of like pipes that are still there. And I mean, it's good that we have the pipes and so on, but kind of they will disappear behind kind of like drywall, and kind of like users will not have to see this. So kind of the only people who are who will be dealing with the pipes are the people who will be laying the pipes. So kind of like the developers will kind of continue to understand for a while longer, kind of like what the value proposition of the different types of pipe are. Sorry, I'm taking this pipe metaphor too far. I'm realizing that now, but I've started, so now I'd stick with it. And kind of like, you know that this pipe does certain things particularly well, and kind of it connects well to this other sort of pipe, and kind of like, but the user, they won't see the pipes. And I think that's kind of, that's already the case in many ecosystems, and I think it's going to increasingly more be the case in the future.
So, so essentially, this abstraction is kind of partially achieved with aggregation of all of these solutions, right? And so then for a user, you're actually like using a single platform, which is aggregating all of these solutions. So now actually, from a user perspective, the resilience is as resilient as that platform is. And like, you know, so that's maybe also...
Yeah, but the complexity of the platform is much lower than the complexity of any one of the pipes. But yeah, I think
I disagree. When you have to integrate like minimum 10 different like bridging solutions into a single platform and maintain all of those routes, make sure that if someone wants to take some really abstract path to get from A to B, because that's the only like viable pathway, I think that's pretty complicated. I don't think that's a trivial problem to solve. And if it was trivial, it would be kind of solved already, right?
Yeah. Let's get Sean's opinion.
I think actually it's great because I'm somewhere in the middle between the two. I think you know, you had mentioned something about like, you know, there's like 5 similar services or something. I think one of the really key problems to getting to this like, you know, unified language, unified interoperability is that these 5 services are actually quite different. I mean, I think this is one of the things that's lost in blockchain a lot. It's like we have a lot of different blockchains providing a similar set of outputs, but the technology stack which they're built on is totally different. The principles, like what they can provide in resilience, they can provide in like decentralization, et cetera, are different. And as a result, also, when you interoperate between 2 different systems, I mean, they both can run smart contracts, they both can like execute things, come to consensus, but like how they do that is totally different. It can affect how the interoperability layer between these 2 also happens. But I do think, so I think there will always be some fragmentation there, and there is, you know, good to be had with specificity with these different platforms. But that being said, I think also agree that there's probably a subset of like commonalities between these chains. Like all chains probably have a token. All chains probably want to do a transfer. We should try to like standardize and unify those things, right? But I think trying to standardize or unify the whole stack actually might be a mistake because it doesn't take into account the really nitty-gritty details about how these blockchains work, and that could actually lead to security problems or other kinds of really nasty situations.
Interesting. So I think Federica made a very philosophical point about this sort of meta decentralization, and that we shouldn't try to maybe unify things. Maybe we should just allow things to kind of crop up, and we just see what survives. I really agree with this, actually. And I think this also brings me to my second point, which is that from a developer perspective, I'm now having to deal with different interfaces for different bridges. Maybe this is not an issue because I'm already a sophisticated user, but from a user's perspective, we're seeing this move to things like intents, which push the need for bridging actually to these sophisticated market actors. How do you see intents as a liquidity solution versus a mint and burn solution, which is actually more capital efficient? And how do you kind of see this playing out? Now, of course, Polkadot, we already have mint and burn, so we don't necessarily need intents, but just eager to get your thoughts on this.
I think intents is it's a clear demonstration of like fulfilling a user demand. And I think in all of these interoperability systems, like people just want to be able to move quickly and cheaply. That's essentially all they're after. Like, obviously, I personally care about the underlying technology that's being used, but from a user perspective, you just want to like do what you want to do as fast and as quick as possible. And so when you have these optimistic rollups with a 7-day challenge window, there's no way anyone's going to wait 7 days to have their liquidity moved off or things like that. So it's really fulfilling a user need. And I definitely agree it's less capital intensive, but it's really meeting a market demand. I think there's a space for both of these things to exist, and it's definitely needed.
I think I really agree, actually. And I think, thinking more deeply, actually intents is a great way to wrap all this different protocol innovation, right? If we believe that allowing all these different chains to kind of try their own hand at, building a good interoperability solution, a good interoperability language, allow them to innovate on that, and intents can be the wrapper, which says, hey, well, as a user, I don't need to understand 15 protocols. I have an intention of doing something, right? And it's really up to the developers who are really deep into the stack to, work with all these different APIs and wrap it up and present the user with something that's much more simple to use. So I think in that case, intents is really like a powerful tool to allow for this kind of like parallelized innovation.
Yeah, I think this very much resonates with kind of like my view of kind of how things should work in the future. And to a certain extent, they already work that way in kind of like on some chains and so on. So basically, a user should be enabled to do something they want to do, and kind of like how it's done under the hood, they shouldn't have to care at all. So this ends up being a developer discussion. Just like I mean, we all use the internet, and kind of we're all tech forward and tech savvy and so on. But like 80% of the world kind of uses the internet, right? And if you look at how many people actually understand TCP/IP, I think it's probably a couple of thousand, right? And kind of like how do you know kind of when you switch between UDP and you probably know, but it's it's kind of like this will be abstracted away from the user, and I think there'll be different ways of kind of handling this under the hood. But I think this is not going to be what makes or breaks adoption for blockchain. So kind of what's that going to be? That's going to be kind of like actually offering genuinely better user experience than people currently have on Web 2 with products that are currently not available on Web 2. So kind of like if you look at the core value propositions of Web 3, to me, they're very much kind of like shared ownership of things and networks and infrastructure and projects and all kinds of things. Then there are agencies, so individualized agencies, so kind of letting you do things that previously you couldn't, because, for instance, I mean, in the financial realm, for instance, you're not an accredited investor, or kind of you don't have $50,000 lying around to kind of have a bank draw up a futures contract for you and so on. So basically, kind of opening that up to the larger population. And then kind of like genuinely better user experiences. And I mean, right now that kind of seems like a little bit of a funny point because user experiences by and large are terrible in Web3. But in principle, kind of if you have permissionless platforms, you can let anyone kind of innovate on what's already there. So kind of say, I have an idea for a killer feature for Google Maps. There's no way for me to kind of add it to the Google Maps stack, right? Kind of like I need to replicate everything that's already there in order to kind of build like this one feature on top. And that's not necessarily the case in permissionless on permissionless platforms. So kind of we can just add things kind of to offerings to the in a way that's previously wasn't wasn't available outside of like open source software. And I think those are kind of like, to me, the three key value propositions. And I think kind of we need to make things that people want to use because they're genuinely better, and then kind of like how it handles, and they will live on different blockchains, and kind of like how it handles interoperability beneath that. I think kind of like it's an engineering problem. We can solve engineering problems. So kind of like I'm very confident that that will be solvable.
Well, I think you guys said everything. I don't know what to add. Maybe one thing I want to add is that bridges are notoriously weak points. So we just need to be careful when introducing new things, and maybe start small and then make sure that the users don't get burned. Let's not burn bridges. Yeah.
Yeah, actually, this actually takes me to my next point, which is, of course, like you just said, bridges are notoriously weak, and they've cost the industry around $2 billion worth of assets. We saw the Ronin hack, the multi-chain hack. All these hacks have something in common, which is that they replace the authorization for cross-chain messages with a multi-sig committee, which then does this attestation. And of course, when they get compromised, you can essentially execute anything in the context of a cross-chain message. So in your opinion, what should be the correct authorization for cross-chain messages? And how can we get to this point where every bridge is using this sort of authorization?
I'm not an expert in bridges, so I'm gonna pass to my colleagues.
Yeah, so I think that again, there's not a single best solution here. So I think one thing that kind of will definitely help, that's already in production in the Ethereum ecosystem, is ZK Lite client bridges that kind of can verify the state of the other chain. Because as you said, that's often how you're duped, kind of because everything that's on your own chain, you can verify, but kind of the things that are crossed from a different chain are things that kind of you can't natively verify on that chain. So kind of like having a light client of that chain kind of running in a ZK environment on that chain, kind of verifying the state of the other chain, that's one way to circumvent that. And obviously there should be different implementations for that, because another way of breaking bridges, of course, is kind of like finding vulnerabilities and kind of like how they work, even if kind of the architecture itself is completely fine, you can still find bugs in a bridge that you exploited. And that kind of also lets you bypass kind of like this multi-sig problem that kind of you raised. The second thing is bridge aggregators. So kind of this is it's something. So we kind of introduced something called hashi. So hashi means bridge in Japanese, and it starts in hash. So we thought this was an excellent name. Something called hashi, and what it actually does is it aggregates so it's a block header oracle. Kind of it looks at block headers as relayed by different bridges between the same two chains, and then it checks, do they actually output the same block header, right? And if you know that the bridges output the same block header, they're either all broken or none of them is broken, right? So kind of what you do is kind of you check like 2 or 3, and if they all kind of give you back the same answer, you use one of them to bridge. And this is a way of kind of, it's a fairly lightweight protocol. It's kind of, because you kind of have to, there's some gas overhead, because you have to make it ask for the block header of you have to make each bridge ask for the block header of the other chain. But in principle, this gives you a way of bridging trustlessly and more or less without any danger, because kind of to break the conglomerate, you actually have to break every single bridge in the same way. And I think kind of like looking at these kinds of hacky solutions, where kind of like, is this super elegant? Well, in some way, no, because kind of like you have found kind of like a unified bridge solution that kind of like bridges everything, kind of like is computationally optimal and so on. Yes, but kind of like looking at several bridges that may not be optimal and seeing whether they kind of all give you the same answer gives you, I would argue, a better security right now. And kind of obviously these systems will kind of harden over time, but kind of like for bridging large amounts, I mean, if you want to bridge like a tiny thing, probably don't want to bother, because kind of you don't want to pay the extra gas overhead. But in principle, if you want to bridge large sums, this is something that absolutely you should use, because it's going to give you, the additive security of all of these different bridges. So I think kind of like having hacky solutions like that, that's perfect for kind of the, you don't agree, Sean? So
I mean, I think that aggregating two untrusted sources does not give you a trusted source. If the cost of maybe compromising these bridges are cheap enough, then it's not unfounded that they will both be compromised for the purposes of attacking a single application. But I can also understand that it does make it a little bit harder.
Not just
there's
a
a
little
space
bit.
for this, yes.
So I think mathematically just doesn't make it just a little bit harder. It makes it kind of, if you say kind of like finding a vulnerability in a bridge is kind of like it costs you $1 million or something, or kind of like, and then kind of finding the same bug kind of for kind of like tweaking the thing in the same, because you don't just need to break them, you need to break them to kind of output the same results. So kind of like, I would fundamentally disagree that it makes it a little bit safer. I think it makes it a lot safer. Yeah.
Isn't one of the bigger risks like liveness of the bridge? Because you can have a bad actor who's always submitting like incorrect block headers, and then they're like essentially censoring the bridge because you could never reach consensus on all of the aggregates in the oracle. Is that?
Yeah, so that's a very good question. So that's a bridge governance question. So kind of like what you want to have. So you want to have multiple people kind of submit these kinds of block headers, and obviously kind of they have to put up some sort of stake, and kind of you can slash them and so on. So kind of that goes into the governance of the bridge itself. But yeah, in principle, kind of there will still be some amount of governance where also kind of that also tells you, for instance, to kind of like stop transfers or what to do after you've stopped transfers and so on.
So I guess like maybe going back to the original question is my view on what should be like the North Star of what we're willing to trust when we work with interoperability is if we want to transact on two chains, then implicitly we trust the consensus of those two chains. So if we have to add in additional trust assumptions on top of that, I think that's, something we should essentially be trying to avoid. So I think all solutions like converging towards that state is like a noble goal. The practicality is a different question, but I think that's ultimately like what, like in the purest form, what people are happy to do, like trust blockchain A, trust blockchain B. I just want to go between them.
Yeah, I think definitely going, talk about North Stars. Obviously, the North Star for all of us is this less trust, more truth, right? And the way that you can achieve truth is through verifiability. And so I think like clients absolutely makes sense. This is what we should be using as a standard. Now it's a little bit difficult, right? I think we also need to think about, there are different scalability solutions. So you can have two different chains with their own security bridging, right? And with that, a light client is about as good as you can get between the two, right? But then, for example, in Polkadot, we have a shared security layer, right? And we are, because of that, able to actually increase some of the assumptions we can make about the interoperability. So one thing we can do here is that we produce blocks and we finalize all of the applications running on Polkadot layer by layer on each block of Polkadot. And that means also that interactions between the different chains, they are also being finalized at the same rate at which we're producing blocks, right? So there are some assumptions you can make about the fact that, for one chain to roll back, or for one chain to, it can't separately finalize from another chain. So that is an additional layer of kind of verifiability you can get from interoperability. And so I think that is also kind of, again, assuming you have a shared security layer, an even better North Star you can try to achieve, right? But really it's all about reducing these spots for trust, reducing multi-sigs, which are that's exactly what it is, and trying to achieve like verifiable knowledge about what is happening between these two consensus systems.
Verifiable interoperability. I love it. I think, I've been researching interoperability myself for the past 2 years, and I think we're now at a fork in the road. There's two directions that we can take towards verifiable interoperability. One of them is, like you said, this purely cryptographic ZK system, where I guess we take ZK proofs of consensus, of state, whatever, and essentially we don't want to introduce any, I guess, cryptoeconomic assumptions about the validity of the computation. And then there's people on the Polkadot side which think, okay, actually you do need economic security if you're going to be able to scale to multiple chains. And actually, they're kind of right, because Polkadot now has 50 blockchains and they're all securely interoperable. So I just want to get the feeling of the panel. What do you think is the correct direction to take?
So I'll start by saying I think we in the Polkadot ecosystem think ZK is very hot. It's awesome. I think the argument I would make, for why we are using like this cynical rollup solution is that ZK circuits and producing them are extremely high overhead. I mean, if we just take you want to do some operation, you need to do it in a ZK circuit. That, as I understand, is about like 10 to the 6 more overhead in computation, and that's kind of like unavoidable due to the magical nature of ZK. It's just, it exists. Now, that doesn't mean that we can't increase computation. We can't increase the ZK stuff to make it, at a point where it's usable by everyone. But and it's like cheap, but it will still have some kind of overhead. So I think the argument we have in our ecosystem is that, hey, if we can achieve similar results but do it in a more efficient way, that could be a good alternative, or provide even cheaper solutions, or provide even more scalable solutions. That being said, I absolutely don't believe that there's one solution for anything. I think you're going to have different flavors. I think there's going to be different trade-offs, different costs involved, and users are going to select what platform they want to use, perhaps multiple, depending on their end-to-end story, right?
Sorry, I feel like I'm hogging the mic here. Yeah, so basically, I think this goes back to kind of like the optimal engineering solution and kind of like what are people going to use, right? So kind of like you can build the best bridge in the world, the most secure bridge, if it's between two chains that people don't want to bridge between, or applications don't, have no demand for bridging between, that's moot, right? So kind of like we have to look at kind of like where are the people, where are the applications, where kind of are the values, and where do we have to move them between different chains? And I think kind of like embedding everything in one system of economic security, that's not going to happen in the future. So I think kind of we will have to rely on different solutions here. And I would actually argue it's a good thing it's not going to happen, but I mean, obviously this is a philosophical point again. So I think kind of like I'm here with Giorgio. So kind of like where do people want to bridge? Why do they want to bridge between those, and kind of just enable those use cases rather than kind of building the optimal engineering environment or the optimal engineering solution.
Actually, I have a question also for you. I think you're working on now partner chains in Cardano. How are you guys thinking about interoperability within that ecosystem? And do you have any plans for also connecting with external ecosystems?
Yeah, sure. So Cardano has developed a very strong community, but has been very siloed because we did not build those bridges initially. And now we are trying to catch up, and we are building different initiatives. One is partner chains, where you can use the Substrate SDK to build kind of partner chains to Cardano and use the security system that Cardano provides. Another initiative that is in its infancy, it's built by us at the foundation, is an IBC bridge. This is being reviewed, security audited as we speak, because we realize that we need to also talk to the other players in the ecosystem. And to answer also your previous question, I think ZK technologies are awesome. I really like them, even if I don't really understand the mathematics behind. I think nobody does. But I see it just as a tool, and we look at, okay, what's the problem? Does it make sense to use ZK or not? And then we use it or not. And yeah. And for the Polkadot ecosystem, I think if you want to also branch out to other chains, I think the partner chains is a great framework to have a look at, because you can literally use your code base and anchor it to Cardano and then see what happens.
Wait, so Cardano, I guess, is going to be validating the blocks of the partner chains, or how is that going to work?
Yeah, the partner chain solution, it's still in an alpha phase, but the idea is a bit the equivalent of what EigenLayer is for Ethereum, so that you get the economic security and the node operator can run additional services. So that's the high-level idea of it.
Okay, nice. Actually, you actually just brought me to, I think, my last point, which is in terms of economic security, there's now two flavors, I guess. There's restaked security, and I guess there's maybe the only one is Polkadot. That's the alternative. What's the panel's opinions on these two different kinds of security? Is there any trade-offs? Because now people are saying, well, we can use this restaked security for bridging, and it's like, should we really be doing this? Please go ahead.
Yeah, I'm glad this is happening, and it's happening in the Ethereum space, because from the Cardano point of view, we can see what happens. We really
guinea pigs.
Yeah, exactly right. It's in this case, I believe it's good to be followers, because I don't think anybody is understanding what's going to happening, because we are leveraging security. And there's restaking, but there's also liquid restaking, and you can kind of leverage security. And if something starts to fall, there's going to be a domino effect with slashing and security consequences. And I'm optimistic. I'm really curious to see what's going to happen. I think it's awesome, but again, we need to be very careful to implement it right, have the right game theory and the right incentives in place. But I'm bullish on this technology. Yeah.
I think restaking is potentially very dangerous. So I think restaking kind of breaks. So basically, staking in itself kind of has a very straightforward value proposition in terms of economic security and so on. But kind of like extending that kind of in a parasitic way to different protocols, that breaks that, and kind of it adds to that, and it makes in principle, very simple process enormously complex in terms of game theory. So I think this is for the entire ecosystem. I think it's not a good development. So I think if you kind of look at how many nodes do you actually need in order to kind of have a secure ecosystem, I think in Ethereum, we're currently above kind of what you need. So kind of like we have 1 million nodes or so. So on Gnosis chain, we have 200,000 nodes. And I think in principle, kind of you can do with way fewer, kind of as you can also see with Cosmos and Polkadot, who have on the order of 1,000 or so. Is that correct? Yeah. So in principle, kind of like having 1 million nodes and then kind of like using them for many very different purposes, I think to me that's risky. I would much rather kind of go into the issuance debate and say kind of like, okay, what's like the optimal number of nodes that we actually want, and then after that, kind of it becomes less. It should become less rewarding to actually validate blocks and kind of like be a block builder, and then kind of we will have a large number of stakers who in principle are equipped to kind of stake, but can kind of stake for different sort of applications and networks. And I think this is where we need to get to, kind of like having the same set and reusing it infinitely. This is going to break, and it's going to break in a really bad way.
I think the instances where restaking is used for bridging, it's because like some of the other solutions that we spoke about aren't really like feasible. So I think it's like, if it's actually solving a real mean, like, okay, that's fine. But I do think, we've all spoken about what we think the North Star should be. And I think that's still really going to be the long-term direction.
I think we're talking about security. I think it's important to like really break down what we mean, and in the sense that it's the harm of like a block being finalized. That everyone is saying that this is the real truth, and it's something is wrong in it, or there's another version of it that someone else thinks is finalized. Like that's the kind of thing, right? And so we're talking about, shared security and economic security. It's like when this situation happens, how much can someone be punished? How much can we disincentivize that situation from occurring? And in that case, I 100% agree. I think restaking solutions is very dangerous, where you have a single token, you're reusing it in 20 different places, and it just increases or multiplies the attack vector to that token, to that value. Like you say, that I have so much Bitcoin being restaked on my chain and providing some value, but if that Bitcoin is also being used in a bunch of other liquidity solutions or stake or DeFi solutions, whatever, then the actual attack cost, can be much lower than the actual value there. That being said, I really think, at least in the Polkadot world, that we have a different approach. Like I don't really consider ourselves restaking, but more like a true shared security in the sense that we have this, again, the cynical roll-up where we don't just wait for someone to say, hey, there is a problem. We actually force validators to check that every block is valid, report, they say, yes, I believe it's valid, and know that they're putting basically their whole stake on the line if something goes wrong. But that being said, I think that I would not encourage, for example, a lot of protocols out there where they would take the DOT token, where we're already providing the shared security platform with a really well understood set of criteria about how we validate blocks, and then have them reuse that DOT in other places for other kinds of protocols that not at least the same token, right? I think that's dangerous. So
True shared security. Heard here at Web3 Summit. So I think there's also another dichotomy here between cryptographic and cryptoeconomic systems, is that a cryptographic system is essentially a centralized system, right? Because a lot like AI, ZK, the end game for ZK is that you just have a single entity that has all the compute power and is able to just churn out these proofs, right? So we're seeing services come out like AgLayer, for instance, and a few of them, which are essentially just proof servers. Versus cryptoeconomic systems that are fully, truly decentralized and cannot censor anyone. What do you think, how do you think that this might play out? As we say that these are the only two solutions in the future, do you think long-term people will opt into these centralized, interoperability solutions that are just basically proof servers, or do you think people would want to see more censorship resistance properties for the bridges that they're going to rely on a daily basis?
I think it's all a spectrum. I really do believe in the multi-chain future in the sense that there will be different protocols. I mean, and they'll provide different layers of offerings in terms of how fast they can provide it, how cheap they can provide it, how secure they can provide it, and you're going to want to use different ones that match your needs. That being said, I think in this space specifically, at the time we're living in, I think we're all we all to give another analogy, like building cars. I think all of us have 4 wheels and an engine, but how safe that car is, there's no safety commission right now. So we're not getting into a lot of accidents. You mentioned a few accidents there, and those people really got hurt. I mean, and the people inside that car got hurt really badly. But practically speaking, a lot of people are building things that work, but under